Of course you are. Probably. There we go. Okay. Go. Bring this back. Boom. There we go. Huh. And I haven't even done anything. Yep. No. Hold on. I'm typing a reminder for people who are going to join at some point. Oh, get rid of that. Come on. Okay. Okay. I'll leave this here. I am coming back to go over these problems with you guys. The lesson obviously won't start till 11:10. Just have to get a few other things set up. But other than that, we're good to go. Or we should be good to go. But we'll deal with that when the time is appropriate. Just getting my windows properly set up. There we go. All right, I'll be back. You're gonna have to explain what. I mean, I know what 100 gigabytes is, but SSD. Maybe it's something I'm not realizing what's going on here. Where is my screen? Oh, solid state drive. Okay. All right. I should get started. Yeah, I have a solid state drive for like a half a terabyte. Well, it's 500 gigabytes, yeah, and it's mainly pictures and videos of the kids, you know. But anyway, I digress. Let me try to zoom in on this a little bit, and we'll get started with this review. So you guys had a practice quizzes, did not count, on this information. And the scores were not that fantastic. They were kind of up and down a lot of the time. So what I would like to do is I would like to review these problems with you one at a time to offer some insight into them before I give the actual assessment on this particular information. I think that would be helpful, to say the least. So in the description to this particular video, you're going to find a link to a Google Drive PDF in which I have the information of the problems that you can click and you can easily see, and we'll go from there. So, make sure I can see these things properly. Trying to arrange my windows in such a way where I can see what in the world is going on when I need it to. So, come on, window. Okay, good. So number one, blank is a sample in which the individual or object in the entire population has an equal chance of being selected. Now, in terms of these words, these definitions, I've never defined quartile for you, but obviously we can figure out what a quartile is. You may have heard that in a previous class. Sample and population. A sample is something you take from a population. A population is an entire group of individuals that you were looking to sample. But blank is a sample in which each individual or object in the population has an equal chance of being selected. That is what we refer to as being a random sample. Now, I have not spoken to you about what it actually means to be random and how proper randomness is actually taken. That is a conversation for another day. It's actually quite intriguing, the different types of samples that can be taken. I'm going to do another lesson on that another day, and randomness as well, but another day. Number two, a student surveys mathematics teachers to get their opinion on teaching. What is the sample? Now think about this logically. You are a student looking to survey mathematics teachers. Who are the mathematics teachers that are available to you? The ones that are in your school. You have to think about this logically and in the context of the problem. All teachers in the world, clearly you'd never be able to do that. All teachers within the school, no, you're surveying mathematics teachers. That's your objective. All teachers except mathematics teachers, ridiculous. It's all math teachers in the school. Now, those would be the ones in the sample. Now, your population is a little bit of a different conversation. Your population could potentially be all mathematics teachers in the world, but for this particular sample, it's just teachers in your particular school. Oh, hey, this is Kyle. Kyle was supposed to be here on Saturday, but he missed out. I just wanted to remind him. Anyway, let's talk about number three. See if we can get that centered on the page there. See if we can get number 5 in as well. Yeah, I can get number 5 in as well. Freeze. Not freezing, but keep it there. That'll work. Okay. Number 3. Kim surveys 100 moviegoers that entered the movie theater in the first hour. What type of sampling method is this? Now, in this particular instance, again, we have to be very careful with how we're wording this particular thing. Technically, I guess you could say that it's somewhat of a random sample, considering that people are entering the movie theater randomly, but not necessarily. You're most likely going to be entering in people that you know that particularly share the same opinion as you. Not to mention people who enter the movie theater in the first hour, people who enter the movie theater to see a certain movie may be of a certain variety or a certain, like, you know, if it's a kid's movie, they're going to be kids. If it's going to be like a romantic comedy, they're going to be like, you know, 20, 30-somethings. If it's going to be a war epic, it's going to be old people, you know. So you can't say that it's a random sample in that sense. So it comes down to convenience or biased. Now, it's definitely a biased sample because it's biased based on what's going on in the movie theater at that moment. But the actual type of sampling that it comes down to is something called convenience sampling. Because, well, for the person who was doing the surveying, it is convenient for you just to survey those people who enter the movie theater, and you don't have to do much in terms of randomness. As the person who is doing the surveying, you have to implement some sort of random selection of people. So we'll deal with that. Again, I'm going to be doing another video on types of sampling, convenience sampling, stratified sampling, cluster sampling, but that's for another day. Number 4. A teacher decides to survey the students in her classes to find out their opinion on the new menu in the cafeteria. Is this biased or unbiased? Now, I could easily just survey, let's say, my Algebra 2 class, whatever Algebra 2 class is there. And I survey everyone in the class, their opinion on the new lunch menu. Ask yourself the question, is there anything about that particular class that would make their responses focused in a certain direction? Is there anything about this class that would cause them to like the menu more or not like the menu as much or whatever? I don't think so. If I'm just trying to survey students in my class, a good assumption is that's a random selection of students who are taking Algebra 2 at that moment. The question that I'm asking them doesn't have anything to do with algebra. It's just about lunch. Yes, it would technically be convenient in that sense, but this would be an unbiased type of survey because there's nothing about the configuration of the algebra class that makes their response to the cafeteria menu biased in any way. Now, if I was asking them something about the Algebra 2 class, if I was asking their opinion on Algebra 2, oh, heck yeah, that would be a biased result. It all depends on the context of the situation. Context means everything in regards to the types of questions that are being asked and how information is being presented. Number 5. A school randomly chose 10 English teachers and asked them what type of juice their students would prefer. Which reason best shows why this sample is biased? It says too small, but like, really? We don't know how small it actually is. I mean, 10. Oh, no, we do know it's 10, but 10 is not that bad in the grand scheme of things, but that's another statistical argument. C, the sample can only be accurate if each teacher is included in the survey. No, that's not what they're trying to find out. They're trying to find out their desire, their objective is to find out the opinion of juice preference in students. The sample did include students. You go to the students directly. You know? I have to figure out something real quick. I want to figure out what the average was for the class. The class average for this particular quizzes. Again, this quizzes did not count against you, the one that we are reviewing. Okay, Okay, Kyle. But let me just see real quick. Designing. Whoa, yeah. You wanted the class average? The class average was 57%. 57%. So it's a good thing that we are reviewing this information. Let's see what number 6 has in store. There's number 6. There we go. Of course you did it, Kyle. Anyway, wait, did you? Anyway, number 6. A controlled study in which the researcher attempts to understand cause and effect relationships by assigning subjects to groups and deciding which treatments each group receives. Cause and effect. I actually have a story about cause and effect that I'm going to share after this particular problem. It's actually, well, it's an anecdote. It's not a story that's happened to me. It's just an anecdote, really, but we'll get there in a minute. No, I don't think I did. Let me double check now. Now you're making me doubt myself. Gotta get to the quizzes website. I want to put my head through my wall. Why is that? Or should I even ask? Kyle, did you take it? Where's your name on here? No, you took it. Oh, because of Kyle. I don't have many responses to that. Anyway, back to this. Cause and effect relationship. The way that we determine cause and effect relationships is by way of experiments. Surveys and observational studies don't necessarily create that cause and effect relationship. Just because you can observe something happening and you see a pattern emerging as a result does not mean that there's a direct cause and effect relationship. Let me tell you an example. In the 1700s, there was a village in Europe in which I shouldn't say randomly, but in one instance, someone observed that a large number of storks had started making their nests in the town. Large number of storks. And it was so much that, again, people had to take notice. Wow, look at all these storks making their nests in this town. Then, 9 months later, a whole bunch of babies were born. This is a true anecdote that people were able to observe. And, well, they saw, well, increase in the number of storks, increase in the number of babies. I thought you said snorks. No, storks. S-T-O-R-K. And so the logical conclusion was, well, there's a direct correlation between the number of storks and the number of babies. Clearly, storks bring babies. Now, obviously that's not true. What could have happened? Well, what ended up happening was there is this type of building that has a chimney on it that storks like making their nests in. And as a result, they kept building these brand new houses with these brand new chimneys that storks liked making their nest in. They liked staying warm near these chimneys. And a bunch of young people, young married couples, moved to this town, built their houses with these brand new chimneys that storks liked, and as a result, a bunch of storks came in. But when you have a bunch of young married couple building their lives together, what's logically going to happen? They're gonna make babies. So, just because two variables correlate does not make a cause. It doesn't do cause and effect. It has to be by an experiment, a well-designed experiment, in order to determine a cause and effect relationship. Anyway, it's a weird story. Number 7. You want to see if students who have a 4.0 grade point average study more than those who do not. Now, what would you do? In this instance, a survey, people could lie on a survey. People are not necessarily truthful on a survey, especially in regards to their grades. So it comes down to an observational study or an experiment. But if you were going to do an experiment, there has to be some kind of a treatment. If there's going to be a treatment, some kind of manipulation to the process, sorry, I just saw your response, Kyle. If there's going to be some kind of manipulation to the process that's going to potentially affect people's GPA, that's unethical. When it comes to experiments, we can only really pursue experiments if they are unethical. So the best way to go about this is observational study. You could potentially get the number of hours that people study based on a survey, but again, they're not necessarily going to be truthful. The best way to go about it is observational study. Number 8. Can you see number 8? Let me bring this screen up real quick, make sure you can see it. Yeah, you can see number 8. Yassine wanted to know what the most popular sport in the world was, so he asked everybody in the whole world. Now, clearly, that's not possible. But if it were, that would be a census. The 2020 census for the United States is actually taking place right now. I got stuff in the mail in regards to it. I filled out my census information. Your parents should have gotten that too. When they fill out census information, that does affect things in the country. They want to know where people are. They want to know where people have moved to. That affects funding of things. That affects laws. That affects the elections to federal government, electoral college, House of Representatives. Fill out your census. Let's look at numbers 9 and 10. Let's bring this up here. There we go. Let's talk about number 9. Which of the following is not a way to choose a random sample of 25? Now, I'm going to go into more detail in a different video as to how to actually go about random samples and selecting them and things of that nature. But let's just go through them one at a time. Assign numbers. Use a random number generator to choose 25. So, for example, if you had a group of 100 students and you needed to randomly pick 25 of them, you would number them from 1 to 100 and use a random number generator to select 25 of them, no repeats. That one's fine. That one's perfectly fine. Good with that. Part B. Put the names in a hat, mix them up, and choose 25. Well, if you had 100 students and each of them wrote their name down on one slip of paper, put all them slips of paper into a giant hat, and you shook well, that's the mix them up, choose 25. That's perfectly acceptable. Yeah. If you didn't mix them up in the hat, if you did not shake well, then that would not be a random sample, unfortunately. It's like what I was talking about in the lesson for this chapter, where I spoke about making soup. And if you put in all the ingredients and then taste it, it's going to taste terrible because you have to mix well. Answer's clearly C, but let's just talk about why. Assemble possible participants in a circle around a person who was blindfolded. Spin the person around 3 times and have them point at a person. Do this 25 times. Now, yes, this seemingly is random. Seemingly. But if you're a person like who's going to be, the one doing the spinning, I mean, like, I don't know, you might end up pointing in the same direction every time. You might, it's not like a spinner. If you actually had a spinner, like one of those things where, just see right here, like an arrow that's like literally spinning around, that's perfectly acceptable. That actually is random. But what they've described here with the actual person spinning around, no, that's hilarious, but that's not a way to choose a sample of 25. Sorry. Number 10. Flipping a fair coin in an experiment is a reasonable way to completely randomize an experiment. Yes. Yes, it is. You want to make decisions, but you don't know what to do, and you want those decisions to be random, flip a coin. Every time you flip that coin, the probability is going to reset 50-50, and you're going to be fine. If you flipped a coin 100 times in a row, and then it landed heads every single time, it's still a 50-50 chance for the next flip. The coin has no memory of what happened before that. So, perfectly acceptable. Let's bring this down for number 11. I am hoping that you all had a nice chortle when you read this problem the first time. Joe Mama wants to do an observational study comparing height and weight. He also does a study comparing weight and calories consumed daily. He concludes that the more calories you consume, the more you weigh. Seems logical. And people who weigh more are generally taller. Therefore, if you eat more, you will get taller. Why is this incorrect? Now, just again, the correlation, you can say that, I'm just going to write this out, calories consumed led to more weight, or these two things were correlated. But then, people who weigh more tend to be taller. Those two things are also correlated. But again, correlation does not indicate causation. Correlation does not indicate causation. If you eat more, you'll get taller. No, logically, that does not make sense in the grand scheme of things. But it's because correlation doesn't equal causation. They talk about a lurking variable here. But lurking variable, it has its own definition. Lurking variables have to do with experiments. You can consider it a confounding variable, age per se, I mean, obviously, but people tend to get taller from birth up until, 18, 20 years old, something like that. But again, that's besides the point. No, correlation does not equal causation. Number 12. A lot of information in number 12. See if I can fit this in here. Okay. Well, the only one that's not on here is E for number 12, but E is not the answer. So this is good. Okay. In a certain school, students can choose whether to eat in a school's cafeteria. They can choose. Now that's important to recognize. A reporter working for the school's newspaper polled students on their reaction to changes in the menu at the cafeteria. For each student leaving the cafeteria in one 20-minute time period, the reporter used a die to determine whether to stop the student and ask how he or she felt about the new menu, implementing randomness. In the reporter's article, it was stated that a random sample of the students showed that 23% of the school student population was happy with the menu. Which of the following statements is true? Well, lots of reading here, and I'm going to assume, no offense to people who took this thing, but I'm going to assume that when you saw all this reading, you may have skimmed it and then picked whichever one you have felt was best. Don't lie. Well, let's just go through them one at a time. A, because each student leaving the cafeteria was randomly selected and could choose to answer or not, this is a random sample of the student population, and the 23% is an accurate measure of the school's population via the new menu. No. It was a random sample, but it's not a random sample of the population. The reason being is actually in part B. Because students self-selected whether to eat in the cafeteria, the sampling method might be biased, and sample might not be representative, key phrase, of all students in the school. If you're going to take a random sample, that random sample has to be representative of the population. But if it's not representative, if there's a reason to believe that it's not representative, then that's going to throw everything into chaos, and it won't be accurate. It won't be feasible, let's just say. The answer is going to be B, but let's just see what C and D and E did. C, the survey would have been more effective if the reporter had collected the data in one 10-minute period rather than in one 20-minute period. What does that have to do with anything? You can't prove that it's going to be more effective. Whatever. Go away, C. D, the survey would have been more effective if students who cared about the food could have called the reporter to tell them how they felt. No, that is voluntary response, so that only students with opinions on the subject would have been surveyed. No, absolutely not. Voluntary response. You can't see E. I'm going to bring this up a little bit. Because no treatment was imposed on the students eating in the cafeteria, one cannot make any conclusion about the new menu. No, there doesn't have to be a treatment. Go away, E. Anyway. Let's talk about number 13. To check the effect of hot temperatures on the elasticity of two brands of rubber bands, one box of brand A and one box of brand B are tested. 10 bands from A are placed in a warm car for 2 hours in the sun, and 10 bands from box B are kept at room temperature. The amount of stretch before the breakage is measured on each rubber band, and the mean for the hot bands is compared to the mean to the others. Is this good experimental design? This would be good experimental design if they had not done two different brands. My son is asking for a piece of paper. Give me 1 second. James, did I give you like 10 before? Oh, goodness gracious. Okay. Yeah, Kyle, I don't think people are really looking at the chat right now besides you. But anyway, back to this. This would be good experimental design if they had done one of two things. One, they chose the same brand and they put in the car for 2 hours and then not in the car and then tested them. Or if they had just gotten rid of that car placed in the sun for 2 hours and then done the experiment. Or put both brands in the sun for 2 hours and then tested them. I mean, but they're conflating two things, which is why the answer to this problem, conflating, confounding, the answer is going to be D. You don't know whether or not it was the brand or if it was the temperature that caused one brand to perform better than the other. You don't know. And because of that, there's confounding. You could design a crazy experiment where, let's say you do, here, watch this. You could do brand A and brand B, and then you could randomly select 10, and then you put 10 in room temp and 10 in hot car. And then same thing with B. This is terrible, but 10 in room temp and 10 in hot car. Can't see that. I'll move it up a little bit. There we go. And then you can compare the results by stretching. Actually, yeah, you can do the stretch. Do the stretch. This is very rudimentary, and then compare, and then compare, and then compare in the end, But that would actually be like somewhat of a decent configuration of an experiment, but again, it would have to be written out much more carefully than what I have done here. Now, there will be an assessment that does count towards this designing a study practice. Not this particular quizzes. I'm going to create something else for it. There will be an assessment that will count, and there will be an additional lesson, online lesson, covering the next couple of points in this chapter. And then we'll kind of go from there. What that like and sub or timeout, don't listen to Marky. Whatever, Kyle. I think some people were in and out. I think at most we're at 5, but now we're at 3 or something like that. But yeah. any who's it's. I am going to, if anyone is interested, I'm going to be back on at 1 o'clock to review some stuff for AP Stat, just like I did yesterday. So if you want to set a timer for 1 o'clock, I will have another live video at that time. But in the meantime, I have a few things to take care of. And yeah, we'll see you guys another time.